A senseless tragedy. 2 lives lost and a valuable helicopter destroyed. This is Major Frank Walker, Commander, Troop A, 3rd Squadron, 5th Cavalry, the unit to which the deceased aviators were assigned. He has been in command of Troop A for a little over a month.
Come in. Good morning, sir. You sent for me?
Yes, Mr. Brewster. Have a seat. I want to talk with you about this report from the Aircraft Accident Investigation Board. I'm very disturbed by the board's findings and want to go over them item by item.
Yes, sir.
Maintenance error. A tool was left in the transmission area of the aircraft after completion of a periodic inspection. Supervisory error. 1, technical inspection was deficient in that the tool was not discovered. 2, tool control procedures were not complied with. Crew error. Inadequate pre-flight inspection in that the tool was not discovered. What do you say to that?
Well, I can't understand it, sir. We've got a good troop. Morale is high. And our accident rate is the lowest in the squadron.
Until this one.
Yes, sir. Until this one.
Although safety is the responsibility of the unit commander, each individual in the unit must be safety conscious. As Aviation Safety Officer, Chief Warrant Officer Brewster assists, advises, and represents Major Walker in all matters pertaining to safety.
Now let's go over the board's recommendations. 1, ensure that all technical inspectors and test pilots conduct thorough maintenance and pre-flight inspections prior to releasing aircraft for flight. 2, ensure that tool control procedures are firmly complied with. And 3, ensure that all flight crews conduct pre-flight inspections in accordance with pilot's checklist. I'll do more than that. We're going to pull an accident prevention survey and find out what other problems we may have in this troop. I want you to organize a survey team made up of you, my pilot, Mr. Johnson, and the safety NCO. Report back to me at 1600 and brief me on how you plan to conduct the survey.
Yes, sir.
Sergeant Goen?
Yes, sir.
Would you come in here, please? Sergeant, we're planning an accident prevention survey. Bring me the personnel information roster and the morning reports for the past 12 months. Yes, sir.
An aircraft accident prevention survey is designed to identify potential aviation hazards in facilities, equipment, and personnel. It is one of the best methods for monitoring a unit's safety program. A survey can save lives and materiel and enable a unit to better accomplish its mission. Prior to the survey, Major Walker obtains the data to complete Section 1, Operational Analysis, in the Guide to Aviation Resources Management for Aircraft Mishap Prevention, a publication prepared by USAVES, the U.S. Army Agency for Aviation Safety, located at Fort Rucker, Alabama. By analyzing the answers to the questions in Section 1, a unit commander can determine the potential weak areas in his command, and therefore most in need of detailed evaluation. Planning a survey is just as important as carrying it out. The Guide to Aviation Resources Management, reports of previous surveys, and a reference file of publications are essential tools and should be used in planning and conducting the survey.
Well, Mr. Johnson, I'd like you to survey operations, aviation training, and aircraft operations. I will cover maintenance and life support. Now, Sergeant Carter, you take POL and armament.
Yes, sir.
Now, we'll be using the USAVE's Guide to Aviation Resources Management. This guide is not a cure-all for our problems. It just outlines the essential tasks and functions needed for a successful safety program. Now, have either of you used this guide before?
No, I haven't.
Only in safety school.
Well, each question listed must be answered by yes, no, or non-applicable. The publication reference for the question is listed on the line below. Now, when an answer needs an explanation, make it on the comment sheet on the opposite page. Now, are there any questions?
Sir, should I take the reference material with me during the survey?
Well, no, but you should review the material just prior to surveying each activity. That way it'll still be fresh in your mind.
Right.
We'll start first thing in the morning. Right now, I've got to brief the CO on how we're going to do it.
Morning, Bob. Good morning. Morning. Sir, we're conducting an accident prevention survey of the troop. Can you give me some time?
Sure thing. I'll talk to you later.
Yes, sir.
Let's go into my office.
Operations is the nerve center of an aviation unit. This is where operating procedures are tailored to meet the requirements of the organization. Among his many duties, the operations officer is responsible for mission planning, mission scheduling, and air traffic control.
Sir, may I see your operations SOP? Does the SOP cover assignments of aviators for specific missions?
Yes, it does.
Does it contain provisions for the appointment of standardization and instructor pilots?
Yes.
Okay, how about ramp checks?
We keep a record of the daily ramp checks made by me or the operations sergeant.
How do you know all the aviators in the unit have read the SOP?
Each aviator processed into the unit must read the SOP and sign his name indicating that he has. Additionally, he must reread it every 3 months.
How do you know what an aviator's training and experience is?
That's all on the status board. Would you like to see it?
Well, not right now, sir. I'd like to go over the SOP first. Can I work on that table?
Of course.
As Mr. Johnson continues with his survey of the operations section, Mr. Brewster is conducting a survey of the company's maintenance activities. Disorganized shop management, unsafe maintenance practices, and inadequate quality control lead to accidents and failure of a unit to accomplish its mission. To eliminate these deficiencies, the maintenance officer must establish high maintenance standards and ensure that an effective preventive maintenance program is developed and implemented.
Well, how do you handle reports of hazards, near accidents, and unsafe practices?
Well, if they pertain to our unit, I do what I can to correct them. If they don't, we submit operational hazard reports.
Are all your men familiar with the OHRs?
Yes, it's one of the things I explain to every new man.
Do you have adequate lighting for night maintenance?
No, about 25% of the lights are burned out. I've already notified the engineers.
Do you have any unqualified personnel receiving on-the-job training?
Yes. Specialist Nelson over there is OJTing for crew chief, and Specialist Castle is supervising.
Do you keep a record of the training?
Yes, all the OJT records are in my office. Would you like to look at them now?
A little later.
Excuse me, sir. You want it on the phone?
I'll be right back.
Well, how are you coming along?
Okay, sir.
Well, while you were gone, I noticed one of the mechanics wearing a ring and a watch.
They know better. Either of you men wearing rings, watches, or ID bracelets?
Yes, sir. I'm wearing a ring and a watch.
Weren't you at the weekly maintenance meeting when Sergeant Tully talked about the number of men who were injured because they were wearing watches and rings while repairing aircraft?
Yes, sir. I meant to take it off, but I forgot.
You should have noticed it, Castle. You're supposed to be supervising him.
Yes, sir. I'm sorry, sir. It won't happen again.
Let's see that it doesn't.
Yes, sir.
What would you like to look at now?
Well, how about the battery shop, sir?
All right.
Hazards observed during the course of the survey should be corrected on the spot if possible. However, they are still recorded for inclusion in the final report. At the end of each day, the survey team meets to discuss that day's findings.
I also found that the unit SOP does not go into sufficient detail on the duties of the crew chief during flight. That's about all the deficiencies I found in operations. How did it go in maintenance?
Well, these are the main things I've found so far. Well, the hangar has insufficient lighting, but Captain Jordan has already notified the engineers. In checking the last 3 months' -13s, I found an excessive number of write-ups being carried forward. Also, some of the write-ups by Lieutenant Thomas and Mr. Benton were vague and incomplete. One of the torque wrenches is overdue for calibration. Oh, and one of the OJTs was wearing a ring and watch while working on an aircraft. Well, that's all so far. How about you, Sergeant?
Sir, I spent most of the day reviewing the armament and POL SOPs. I'll begin making an actual survey tomorrow.
Okay. We'll meet again at 1600 tomorrow and compare notes.
For the next few days, the survey team continues its accident prevention survey of Troop A. The survey covers every activity in the unit. For example, the unit must provide training for aviators in many subject areas. This includes individual aviator flight proficiency, knowledge of aircraft operating limitations, and use of flight simulators.
Are checkouts given to aviators in the unit to ensure standardization and proficiency?
Yes. As you saw, the status board shows when each aviator's stand ride is due.
Do we participate in the squadron standardization board?
Mr. Williams, the troop stand pilot, attends meetings along with Mr. Brewster.
How often do you hold classes on the -12s, 13s, and 14s?
We discuss them at the first safety meeting of each quarter.
Sir, may I see the orders appointing our IPs and SIPs?
I'll get them for you.
Safety precautions in the handling of petroleum, oils, and lubricants cannot be overemphasized. Personnel working with aviation fuels and oils are continually subjected to health, fire, and explosion hazards.
I'd like to check the hose and nozzle for leaks. Okay. Petty, start it up and circulate some fuel. Are the dates of the filter changes stenciled on the filter housings of all tank trucks? Yes, they are. Now would you like to go up on top and check the nozzle? I see you've got a leak there. What about that, Petty? I'll take care of it. Does everyone in the section know the hazards of spilling JP4 on their clothing or skin? You know, I'm not sure. We got a couple of new men in last week. Well, you better make sure. Fuel can destroy the natural fats and oils in the skin. This causes dermatitis, which can lead to infection. Okay, I'll make sure they all know about it.
The unit commander must ensure that proper procedures are established and complied with by all personnel involved with flight. This includes pre-flight, starting, run-up, takeoff, hovering, and landing.
Well, I see you have plenty of fire extinguishers handy for engine starts. Are the aircraft being pre-flighted from checklists and not from memory?
Yes, they are. There's one being pre-flighted over there.
Electrical compartment.
Check.
Access doors.
Here. Good morning.
Good morning.
Good morning. And
While it is important to make comprehensive notes during the survey, it is equally important to do so as inconspicuously as possible. If people feel they are being watched for mistakes, they will resent it.
Well, we've got to get going.
Well, have a good flight.
Thank you. Turbo to drive shaft coupling.
Position and secure. Sir, I'd like to take a look at the fuel sample bottles.
They're over here.
The Army has devoted considerable effort and money towards the development and procurement of equipment to protect aviation personnel from injury. This equipment is of no value unless it is on hand, properly fitted, maintained, and used.
Are you short any Nomex flight suits, gloves, or flight helmets?
No, Jim. Every crew member in the troop is fully equipped.
How do you ensure that each man's flight helmet fits him properly?
The squadron flight surgeon checks for proper fit during a new man's medical limb processing. He also checks the helmets during annual flight physicals.
Have you had any defects in any of the life support equipment?
Yes, we've had several pairs of Nomex trousers with defective zippers.
Well, what did you do about them?
I made out EIRs and turned them in.
Well, may I see the EIRs?
Sure.
Armament is a very sensitive area. There is potential danger here, not only for armament personnel, but for all unit personnel who work on or around armed aircraft.
Sir, do you have plenty of cleaning equipment for the weapon systems?
Oh, yeah, and we use it, too. In fact, we've never had a rocket hang fire due to a dirty tube.
What precautions are taken for rockets which are exposed to temperatures above their normal operating range?
If the temperature exceeds the normal limits, they are not fired until normal range is reached. And they're left at that range for a period of at least 6 hours.
What procedures do you take for each range during firing?
We have a range SOP that...
At the conclusion of the survey, the team meets to compile its findings. This will provide the basis for establishing priorities in dealing with accident potentials. A summary briefing will be prepared for the unit commander, which will include all significant findings and recommendations. In addition, a formal report will be prepared and filed for future reference. After the survey team's report has been thoroughly evaluated, Major Walker makes a determination of the action to be taken to eliminate the weaknesses in his troop.
Gentlemen, judging from the number of weaknesses this survey has revealed, it appears this troop is beginning to slide downhill. Obviously, the area which needs attention most is maintenance. It is significant that the findings of the Aircraft Accident Investigation Board included maintenance error. Now, we must improve our maintenance, and we must do it immediately. If not, we may have another accident on our hands. First Sergeant?
Yes, sir.
Have the maintenance officer here at 1400 this afternoon. I also want to see the operations officer and all the platoon leaders at 1600.
Yes, sir.
Mr. Brewster, beginning tomorrow morning, I want you to make certain that...
Mission accomplishment with 0 accident rate is the primary objective of the U.S. Army Safety Program. Experience has proven that high levels of sustained performance can be achieved only through effective management of all segments of the command. Properly administered, an aircraft accident prevention survey can reveal the weaknesses or potential weaknesses existing in a unit. After analyzing the deficiencies, the aviation safety officer and safety NCO will recommend changes in policy, procedures, and facilities which will help prevent future accidents. The commander will then take appropriate action to ensure that his unit will operate with maximum efficiency at minimum risk.
During a recent 2-year period, 33 Army personnel were killed by tail and main rotors while entering, leaving, or working around Army aircraft. It is of paramount importance that during your training, you learn, master, and at all times thereafter, follow the safe procedures for entering or leaving aircraft to protect yourselves from tail rotors and main rotors. The following rules must be observed for safe boarding of helicopters. First, be sure the helicopter has fully touched down. The pilot must be sure that the helicopter's rotor system is level. You must always use caution when approaching an aircraft, whether as a passenger, refueler, mechanic, or loader. You should approach a helicopter within range of the pilot's vision. That is, within an area 90 degrees right or left of the nose of the helicopter. Never go around the tail. Radio men must ensure the radio antenna they are carrying does not protrude upward in such a manner that it will come in contact with the rotor blades. Of course, if a fixed-wing aircraft is involved, and for any reason you have to go around it, you must go by way of the tail to avoid the plane's propeller. You must always keep in visual contact with the aircraft you are approaching. With the OH-6A or the OH-58, you have a special problem. After being sure the pilot has fully touched down, approach this helicopter with even more caution, if that is possible, because of the unusually low rotor blades. A combination of low rotor speed and high gusty wind increases the hazard to personnel in the immediate vicinity of the aircraft. When leaving the aircraft, the same rules apply as on entering, and be certain that all loose items have been secured. The dangers here are apparent. In loading and unloading internal cargo, the same rules for personnel safety apply. Always be alert and keep low. It is a safe habit to get into and keep. It can save your life. In the case of the CH-47, the pilot must be sure that the helicopter rotor system is level and the aircraft is fully touched down before loading troops or internal cargo. When loading or unloading personnel and/or portable cargo, the loading ramp should be approached only from the right or left of the helicopter's tail within a 45-degree fan area on either side of the aircraft. This is to avoid the excessive exhaust temperatures directly behind the aircraft. Under normal conditions, the CH-54 tail and main rotor blades present no problems in coming in contact with personnel on the ground. But remember, it is a helicopter, and precautions must be taken. You must always look out for blowing objects caught up by the rotor wash. In addition to tail rotor and main rotor blade hazards, armed helicopters, such as this Cobra AH-1G, present additional dangers through their weapons systems, and they should be approached with extreme caution. When operating in rough terrain and/or combat situations, you must give close attention to the aircraft commander's instructions for departing or entering the helicopter. In extreme conditions of terrain, where the helicopter cannot fully set down, close coordination must be maintained between crew and passengers to avoid dangerously low rotor blades. Passengers must be instructed how to exit the aircraft on the upslope side of the helicopter, where the tail and main rotor blades are nearest the ground. The same precautions apply to any model of helicopter used in this kind of situation. When operating in an open terrain area, personnel must always be on guard for loose objects on the ground, which may be blown around by the rotor wash. Rotor wash effects increase in proportion to the size and weight of an aircraft. These helicopters are directed in the refueling area by ground personnel who should be dressed in proper work uniforms, wearing eye goggles and leather gloves, sleeves rolled down and buttoned, and leather boots. Dress in this manner protects personnel from flying debris and any fuel spilled during the refueling operation. When the aircraft has been parked in its proper refueling position, you wait before refueling to ensure that the aircraft rotor system is level and until you receive your go-ahead signal. The aircraft should be maintained at full operating RPM to facilitate aircraft clearing the area in case of fire in an adjoining fuel point. The crew chief gets out, opens co-pilot and pilot doors, slides armor shield to rear to make it easier for crew to escape in case of fire. Passengers must get off the aircraft and move to a safe area. All crew members will have their visors lowered. After assuring there are no open flames or smoking in the area, the crew chief with fire extinguisher in hand supervises the refueling operation. The refueler grounds the aircraft and attaches the nozzle grounding cable. The crew chief checks for proper grounding. The refueler removes the fuel cap, places the nozzle fully into the filler port, and begins refueling. Once the closed circuit system is attached to the aircraft, the refueling is automatic. In case of an emergency departure, the nozzle will disconnect. This is a design feature of the closed circuit system. This system may also be used to refuel manually. The crew chief must be in a position where he can see both the pilot and refueler, so he can signal between them. After reaching the desired fuel load, as indicated by a signal relay from the pilot by the crew chief, the refueler stops the fuel flow. He removes the nozzle, replaces the filler cap, disconnects the nozzle and aircraft grounding cables, and returns the nozzle to its rack. The crew chief returns the fire extinguisher and readies the aircraft for flight. The passengers are reloaded. These procedures may vary due to the configuration of the aircraft and type refueling system used. Personnel working around the OH-6A must use extreme caution due to its extremely low rotor blades. In addition to the low rotor blade danger, there is always a possibility of fuel feedback during manual refueling as the explosive fuel is flowing into the fuel tank. With the UH-1C and the UH-1M series aircraft, extreme caution must be taken in manual refueling due to the location of the refueling port. The same is true of the AH-1G Cobra. The fueling port is higher than normal and located near the engine air intake. If the nozzle slips out of the fueling port, or if a surge of fuel flow causes spillage during manual refueling, it could go into the engine, causing excessive acceleration, possibly damaging the engine and the driven components or start a fire. The closed-circuit system shown will eliminate all of these hazards. The closed-circuit system should be used on all aircraft when possible. The CH-47 helicopter, while big and high, has front rotor blades to watch out for. In a high wind condition, all blades are dangerous to personnel because they can flex down lower than normal. But the front blades are more dangerous as they are the lower of the two rotors. The flight engineer must be in a position to supervise refueling on both sides of the aircraft because there are fuel tanks on opposite sides of the helicopter. He must maintain communications with the pilot at all times. The CH-54's special problem is the location of its exhaust near the refueling port and the excessive heat it puts out. In this case, we shut the #1 engine down to avoid the excessive exhaust temperature on the refueling personnel and the open fuel port. This applies to both manual and pressure refueling. Prior to arrival of the aircraft, the sling loading hookup area should be cleared of all loose objects that might be thrown about by rotor wash. Only personnel involved in the operation should remain in the area. On arrival, the pilot in command will determine that the ground personnel are positioned and ready for the hookup. The signalman must maintain a position 30 to 50 meters in front of the load facing the aircraft, where he is in constant view of the pilot. When hovering toward and over the load for the hookup, the pilot follows the signalman's directions. While the helicopter is over the load, the aircraft crew and hookup crew must be constantly alert for possible engine failure. It cannot be overemphasized that due to the nature of the turbine engine, a power loss or engine failure may occur with no warning to either ground or air crew. Constant alertness is imperative. Engine failure. The pilot releases the load. The signalman turns away from the aircraft and dives to the ground. The hookup man dives and rolls as far to the right as possible. They cover their heads with their arms to protect themselves should the helicopter crash. The pilot executes an auto rotation to the left of the load. After a normal hookup, the hookup man will move to the right and forward. The signalman will direct the pilot as he lifts the load, checks for other aircraft in the area, and clears the pilot for takeoff. The same general safety rules apply with the CH-47, except that no signalman is used. His duties are performed by the pilot and the flight engineer, who can effectively observe operations through the floor hatch of the aircraft. During hookup, static electricity on the cargo hook cannot be effectively dissipated from within the aircraft. Electric shock can be avoided by grasping the rigging donut with gloved hands. With the CH-54, safety rules are similar. No signalman is used, as his duties are performed by the pilot and flight engineer. They can effectively observe operations from their positions in the aircraft. Static electricity is not normally a problem. The loading scenes just shown do not cover all types of sling operations. Other loads, such as ammunition, heavy weapons, and vehicles, involve safety procedures peculiar to these types of loads. Standard procedures for handling various loads and aircraft should be reviewed frequently and followed by all personnel concerned. This will promote greater safety during this hazardous operation. When moving and parking aircraft on an airfield, all movements will be coordinated and controlled through the aircraft traffic controllers located in the airfield tower. Only designated hovering lanes and parking spots should be used. Hovering lanes and parking spots are indicated by painted stripes, airfield lights for night work, or other indicators. Their usage varies with the airfields, and a complete explanation of each airfield can be found in the operations office. Aircraft crews will familiarize themselves with the correct procedures of the airfields they will be utilizing. When moving and parking on an airfield, the aircraft crews should use caution to avoid maintenance vehicles, maintenance personnel, other aircraft, and miscellaneous personnel and equipment which might be located on or near the hovering lanes and parking areas. Personnel on the ground should avoid positioning themselves or any equipment in any location that would obstruct aircraft movement. Any loose equipment should be secured whenever rotor blades are turning in the area. Aircraft crews observing any safety hazards on an airfield should avoid them and make a report immediately to the ground controller. Landings at other than established airfields, such as rough or unprepared terrain, will involve ground movement and parking procedures which are different from the normal ones. The pilot in command is responsible for safely moving and parking his aircraft. If no ground handling personnel are available at rugged sites, movement is accomplished by full utilization of his crew to avoid any obstacles or personnel in his path on all sides. Because the CH-47 is so large and has limited visibility, ground handling personnel are required to safely move the aircraft when operating in a restricted area. Ground handling personnel should be utilized in conjunction with the crew on board to safely move the aircraft. If ground handling personnel are not available, a crew member must be dismounted and used instead. To avoid confusion between ground personnel and the aircraft crew, ground personnel must be thoroughly familiar with and use only the standard hand and arm signals and equipment described in Field Manual 21-60. They must be familiar with the requirements and procedures for both day and night operations for each type of aircraft. Ground guidance personnel must be fully dressed in proper work uniforms, goggles and ear protection, gloves, and a fully serviceable uniform. The position of the signalman when directing utility aircraft is in front of it, where he can best be seen by the pilot. A special caution when directing armed helicopters, such as the AH-1G Cobra. The signalman must not position himself directly in front of the aircraft at any time. Stay to either side of the front. With the CH-47, caution should be used not only to avoid direct contacts between the rotor blades and other objects, but to prevent damage resulting from rotor wash and flying debris. Maintain as much distance as possible between the aircraft and any possible item which may be damaged. All aircraft crews must be dressed in complete flight uniforms to include flight helmet, Nomex gloves, the Nomex flight suit, and leather boots. At all times, helicopter engines are being started or are running. Helmet face shields must be down during refueling operations. SPH-4 helmets should be worn by crew members for ear protection. Ground personnel must wear protective earmuffs. Uniforms must be fully serviceable, that is, no holes, no rips or tears. During cold weather operations, additional clothing may be desirable, but movement or vision must not be restricted. Maintenance personnel must be fully dressed in proper work uniforms. They should wear Nomex suits if available. When near a helicopter, remember to remain well clear of the tail and main rotor blades. On some helicopters, the main rotor blades are low and extra caution is necessary, especially during high wind situations. Caution around turning rotor blades cannot be overemphasized. Aircraft require proper grounding during refueling operations. Avoid fuel overflow, feedback, or sloshing out. Fire is a great hazard. Hookup teams, properly positioned and well briefed on procedures, minimize dangers. Ground handling and aircraft crews must be thoroughly familiar with and use only standard hand and arm signals. Aircraft crews must be properly dressed during all aircraft operations. Properly dressed ground crews minimize exposure to flying debris. Every aircraft has its own inherent dangerous characteristics. Your life depends on learning and following standard safety procedures. The time to start is now.
Our business is aviation maintenance. Our goal, safety. As a maintenance man, your primary job is to ensure efficient operation of aircraft and equipment. You are also charged with the responsibility of avoiding injury to yourself and to those around you. Now, one way to accomplish this is to perform your job as if your life depended on it. Sometimes it does.
Serious injury, or worse, a man is not alert. This pilot is in trouble. A sudden loss of power, auto rotation. Improper maintenance can result in costly damage to aircraft and injury to personnel. All because the main fuel line quick disconnect came loose.
For every accident, there is a cause. And we in aviation maintenance want to know why and what we can do to prevent it from happening again. Here on the flight line and in the shops, the accident potential is high, and maintenance personnel must be ever alert. Accidents don't just happen. They are caused by thoughtlessness. He just isn't thinking. And somebody's bound to get hurt.
By being thoughtless, this man is not interested in the quality of his work. He just wants to get it over with. Count the tools? Not for him. He gambled. The crew lost. Old Sarge here has been a wrench bender for years. Him use a torque wrench? No. Pull it up tight, and then a half turn is good enough for him, even when he's dead wrong. Finally, he causes accidents and injuries by being afraid to ask. This young fellow is new on the job. He needs guidance. But he's going to be a hero and try to do it all himself. How do we know? The evidence speaks for itself.
A good mechanic takes his work seriously. Maybe nobody's ever told him so, but he knows he's the most important man on the field, even more than the pilot.
An aircraft can be flown without a pilot aboard, but an aircraft cannot be maintained without the personal touch of a mechanic.
Our seasoned mechanic has the desire to do the best job possible. He does it by the TM, using proper maintenance procedures.
I do it by the book because that's the right way to do it. And I want to be right, 100% right. Anything else could be fatal.
Safety belongs to everyone. It is the product of an efficient organization, a function of management, proper planning, and supervision. When all work smoothly together, aviation maintenance will show an increased mission capability, along with a reduced loss of manpower and material. To create an atmosphere of enthusiasm for working properly, the greatest tool a supervisor can use is communication. This leads to understanding and results in binding the organization together from top to bottom and from bottom to top. Supervisors cannot stand over each mechanic, but by building an environment for outstanding work on the part of everyone, it will reduce the possibility of error. A clean, well-arranged hangar is a safe hangar. Keep floors and aisles clean and free of all obstructions and slippery substances. Oil slicks are a menace. A drip pan should always be used. All hangared aircraft must be grounded by a cable attached to a structural member of the aircraft. Fire hazards are a constant threat in the hangar, where sparks, friction, or careless handling can cause a serious fire. Ensure the presence of an appropriate fire extinguisher properly placed and in serviceable condition. No smoking, except in designated areas. Be aware of the hazards that exist by smoking in the hangar. The Surgeon General has warned that smoking is dangerous to your health, and perhaps in more ways than one. A first aid kit available for instant use is a must. Any shop where tools and materials are handled requires observance of common safety practices. It may be the welding shop, paint shop, or machine shop. Each has its own safety rules and procedures, but the principles are the same. Safety and awareness are the key. Report for work properly dressed, sleeves rolled up, uniforms free of loose or ragged edges that might catch on equipment. All jewelry and watches are hazards and must be removed. Needless to say, power tools that are properly adjusted are safe tools, and unsafe tools must be repaired or removed from service. Electrical tools must be connected to a low-resistance ground.
How's it going, Wisdom?
Just fine, sir.
You ready when the TI inspects the hangar bearings?
Yes, sir.
Good. Safe living means the ability to function in the presence of necessary hazards. And the flight line is a hazard course. To function properly, you've got to be alert at all times and observe all safety procedures.
Aircraft must be started, run up, and checked only by qualified personnel designated by the unit commander. Be sure that no one is working on the aircraft and that all personnel are standing clear. Be alert for hot exhaust temperature of turbine engines and avoid rapid throttle accelerations which may swing the tail abruptly. Before leaving the cockpit, always double check that the battery switch is off. In towing aircraft, be sure that the main rotor blades are tied down and that the ground handling wheels are properly mounted and the tow bars secured. Observe the towing speed limit and all safety requirements of the airfield, including the use of the special towing lane. Be particularly careful when you move a helicopter into a hangar, ensuring proper clearances from other aircraft, structures, and equipment. For fixed-wing aircraft, ensure that wing walkers are in position and that there is a man in the cockpit. Take care when using work stands. 2 men should be used in moving the stands, one in front to guide, the other to push. Don't forget to lock it in place and be sure to use guardrails. Store all ground support equipment properly in a centralized area to reduce hazards. As with other equipment, cleanliness is essential for safety. Which brings us to a very dirty word in aviation, FOD, foreign object damage, and with good reason. Half of Army aviation turbine engines in overhaul will show some erosion and FOD.
problem of FOD goes hand in hand with the turbine engine, which sucks up anything within range. FOD can be caused by straw, which clogs the air inlet guide vanes. Small pebbles, bits of wire, and debris, which can set up a chain reaction of ripping and tearing at the inlet guide vanes and the compressor blades. Zeus fasteners sometimes come loose from the cowling. They are sucked into the intake to the compressor, where they bang around, chewing away at the blades, and often tearing the blades completely off the compressor. The sad part of all this is that maintenance personnel themselves account for a good part of FOD.
Tools, rags, paper cups, nuts and bolts are often left to cause trouble for some unfortunate aviator. At best, this is sloppy housekeeping. At worst, it's toying with somebody's life, because most of it can be prevented. Even sand is murder on a turbine engine. A properly trained unit can develop the kind of pride needed in the war against fog. Alertness, professional pride, and responsibility are the tools to use in this fight. Fuel contamination. Most often, the fault is found in storing, handling, or servicing after the fuel has been received on post. Our goal in the fuel handling chain is to service our aircraft with the cleanest fuel possible. Water is a real villain. When it gets into the fuel line, it can play havoc. That's why sump draining is most important. The sad result of poor handling is to risk lives and property. This means that you must make absolutely certain that the right fuel is always used and that it stays clean. Safety precautions in the refueling operation cannot be overemphasized. Personnel involved in the handling of aviation fuels are continually subjected to health, fire, and explosion hazards. For your own protection as a fuel handler, you must be thoroughly familiar with your duties. All aircraft fuel servicing must be conducted out of doors. Permanent ground rods must be installed at each fueling point and circled with a yellow and black ring. Ground rods must not exceed 10,000 ohms resistance. The fueling vehicle must be at least 20 feet from the vents of the aircraft during fueling or defueling operations. Aircraft fuel vents or fuel tank openings must be at least 50 feet from any building or hangar and at least 300 feet from all radar operations. Wind direction will be considered so that fuel vapors will not be blown toward an igniting source. A fully charged 50-pound fire extinguisher will be located strategically during fueling operations. Fire extinguishers on vehicles and aircraft will not be obstructed. A static ground cable must be connected from the servicing unit to the ground. Aircraft to ground. And from aircraft to servicing unit. A standard Y cable is appropriate. Ground the fuel nozzle to the aircraft prior to opening the filler port. If available, wear protective gloves and helmet visor or goggles over your eyes. And be sure your clothes are completely buttoned. Remember, in refueling, you're playing with fire. Don't get burned. Do it right. For other safety precautions during fuel servicing, consult TM 10-1101 and be sure. Weapons servicing and maintenance is another area where proper safety precautions must be adhered to. Prior to servicing and maintenance, follow all caution, warning, and general safety procedures outlined in the Technical Manual 9 series. But let's consider some basic safety steps for all systems and munitions. Position the aircraft so that the weapons will be aimed into a clear or downrange area. Do not force, twist, or rotate any weapon. Immediately install safety devices such as the bullet catcher. Remember that moving or turning components will often activate the weapon, causing it to fire. Be sure that the aircraft is grounded, that all electrical and armament switches are off, that armament circuit breakers are pulled out. On some systems, the battery must be disconnected before maintenance can be performed. When unloading weapon systems, be sure personnel are clear of the forward and aft firing and/or blast areas. While it is proper to unload the weapon systems from the front, it is regarded as much safer to approach the operation from the rear in the event of a sudden triggering of a rocket or missile. Unload the outboard weapon system first, then the inboard. Always unload the turret last. There are two parts to this operation. First, the 40mm sized shells that are located on the left side of the turret. Second, the minigun located on the right side of the turret. Place unused rockets and ammunition in clean containers and return to relinking area or magazine. When it comes to loading ammunition into the Cobra, reverse the unloading procedures by starting with the turret. In loading the minigun, be on the lookout for damaged cartridges. Any deformed or damaged ammunition, rockets, or missiles could cause weapon jamming or misfire. After loading the turret, load the inboard weapon system first, then the outboard. Use appropriate technical manuals and understand all special test equipment. Some test units can activate the first firing sequence without wiring or power. The mark of a good mechanic is the man who always uses the right tool for the job. The wrong screwdriver may strip the head of a screw. The wrong wrench will round off the head of a nut. Avoid the use of cadmium-plated tools. They will flake and the chips may stray into an engine oil system. The proper technical manual is your Bible for maintenance. Live by it. It will provide step-by-step procedures for anything you may want to know. How to remove, inspect, and reinstall parts. The TM will help you in another vital area, that of torque. Fasteners must be installed to a definite degree of tightness. The torque wrench, properly used, will give you the required amount of tightness for a fastener. Under-torquing invites early fatigue failures or the possibility of a fastener working loose. Over-torquing results in permanent elongation of a bolt and a loss of strength. Be sure to consult the TM for proper use of torque values. It will also tell you which wrench to use and where to apply it.
Anytime you're performing maintenance, you may tend to forget that you're part of a safety management team, totally dedicated to the prevention of accidents causing injury and/or property damage. It's an ongoing program of inspection standards concerning training, education, and engineering.
But no amount of outside influences can have any meaning unless you yourself develop an awareness for safety. Any satisfaction derived must come from you, from the confidence and trust of the aircraft crew, and especially from the self-esteem that comes with the respect of your unit. When you can feel those things, When safety becomes second nature, you've arrived as a maintenance man, taking your place with the professionals, leaving you with the satisfaction of a job well done.